All right, so chapter 8, section 4 is called Properties of Rhombuses, Rectangles, and Squares. Those are the three special types of parallelograms that we're going to talk about in this section. So definitions first. Okay, a rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is a parallelogram with 4 right angles and 4 congruent sides. So if a rectangle and a rhombus had a baby, it would be a square. So notice each of them say a parallelogram with blank. A parallelogram with, a parallelogram with, which means that all 3 of these have all the characteristics of a parallelogram. All 3 of these have opposite sides parallel. All 3 of them have opposite sides congruent, opposite angles congruent, and diagonals that bisect each other. And then consecutive angles that are supplementary. It's just that now we have an additional property to add to each of those. So rectangles have all 5 of that, plus all those angles are right angles. Rhombuses have all those 5 things plus 4 congruent sides. And then squares have all those 5 things plus the right angles and the 4 congruent sides. So based on those definitions, these are corollaries, which the rhombus corollary says a quadrilateral is a rhombus if and only if it has 4 congruent sides. And if and only if means it can be read both ways. So either the quadrilateral is a rhombus if it has 4 congruent sides, or if a quadrilateral has 4 congruent sides, then it's a rhombus. So that's why it's written both ways. The rectangle is a quadrilateral is a rectangle if and only if it has 4 right angles. So if it's a quadrilateral it's a rectangle, then you know it has 4 right angles. And if it's a quadrilateral that has 4 right angles, you know it's a rectangle. And then the last one, if a quadrilateral is a square, a quadrilateral is a square if and only if it is a rhombus and a rectangle. So if it's a square, you know it's a rhombus and a rectangle. And if it's a rhombus and a rectangle, you know it's a square. So those statements can be written both ways. So for the first one, the little diagram that's there, all 4 of those sides are marked as congruent. So this is a rhombus if and only if all 4 sides are congruent to each other. The second one's a rectangle. This is a rectangle if and only if all 4 angles are 90 degrees or right angles. And then the last one's a square, which is the combination of the 2. This is a square if and only if all 4 sides are congruent and all 4 angles are right angles. So this is a Venn diagram. I don't know if you remember Venn diagrams, but a Venn diagram is something that if I take the big box, so the big box is parallelograms, and then I put these things inside the big box. So everything inside the large white box is also a parallelogram, which means a rhombus, a square, and a rectangle are also parallelograms. And then if I take the rhombus and the rectangle and overlap them, then it has all the properties of both, which would be a square. So we're going to come back to this in a minute, but I'm going to fill this in with all the properties that have to deal with each of these individual shapes. What do we know about the properties of a parallelogram?
Diagonals are perpendicular.
Nope, not perpendicular. Opposite sides are parallel. Remember, there's 5 things, Camilla. Opposite sides are congruent. What else? It's only been 24 hours, folks. Chris. Good. Diagonals bisect each other. Emily. Good. And the last one, Alexis. That's proving it's a parallelogram, right? So we want to go the other way around. If it is a parallelogram, there's one more property that we should know. Emily. So good. Consecutive angles are supplementary. So all 5 things of these are true about a parallelogram. And then because a rhombus, a rectangle, and a square are parallelograms, it means all 5 of those things are also true for all of those. Okay, so now let's go to rhombuses. So what are the properties of rhombuses we just learned about? Nick. Diagonals are perpendicular. What else? What's the definition of a rhombus? It's on the slide. 4 congruent sides, okay? There's something else you know about a rhombus. Go back a slide. Mm-hmm. Good. Diagonals, bisect, opposite angles. Okay, so 3 things that are true about a rhombus, in addition to all the properties of a parallelogram. Let's go over to rectangles. So the one property is right there on the screen, right? What's the definition of a rectangle? 4 right angles, a quadrilateral, or a parallelogram, sorry, with 4 right angles. What's the other piece of information we just learned about rectangles? Good. Diagonals are congruent. So then, because where these 2 overlap is the square, it means all of the properties that you see that we just wrote in on this screen apply to a square. So a square has opposite sides parallel, opposite sides congruent, diagonals that bisect each other, consecutive angles supplementary, diagonals that are perpendicular, diagonals that are congruent, and diagonals that bisect the opposite angles. 4 congruent sides and 4 right angles. Okay, so all of those properties trickle down. Does that make sense? Yes? Okay. So in addition to the property you know because it's definition, there are other things true about these objects. So a parallelogram is a rhombus if and only if its diagonals are perpendicular. So because it's a parallelogram, the diagonals are bisected. And then because it's a rhombus, they are perpendicular. So either I can say this is a rhombus because the diagonals are perpendicular, or I can say if it's a rhombus, then the diagonals are perpendicular. 8:12 says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So we already knew the angles opposite were congruent. Now with a rhombus, we're saying that they are also bisected. So in this diagram, if it's a rhombus, then angle DAC is going to equal CAB, and ACD is going to equal ACB, and ADB is going to equal BDC, and the last one, ABD, is going to equal CBD, and vice versa. If all of those are true, then I know it's a rhombus. And then the last one is about the a rectangle. A parallelogram is a rectangle if and only if the diagonals are congruent. So we knew they were bisected before, but now we know if they're a rectangle, that they are congruent. So what would be true? What of these would be true about a square? All of it, right? Right? Does that make sense? So a rectangle, everything that's true about a rectangle is also true about a square. Everything that's true about a rhombus is also true about a square. So in a square, the diagonals are perpendicular, the diagonals are congruent, and the diagonals bisect the opposite angles. Anybody still coming down? All right, so actually, okay, it says quadrilateral, A, B, C is a rhombus. Find the measure of each angle. So I'm only given one angle. What else do I know about these angles? Not a rhombus. You're thinking rectangle. So, but what do I know about what happens where that diagonal hits angle BCD? It's bisected. So if this is 62, then this is also 62. And then it's a parallelogram, which means the alternate interior angles are still going to be congruent. This is 62, and this is 62. The opposite angles are still congruent and bisected, so they're still in 4 congruent parts, okay? And then take on the properties of parallelogram. What would be true about this angle and this angle? They're supplementary. So if I add 62 and 62, I get 124. Subtract that from 180, and I get 56 degrees. So this whole angle is 56, which means each little part would be half of 56. You with me so far? Which is 28. So this big angle is 56, and this is 28 and 28. And then there are 4 more angles in there where the diagonals meet. What do I know about those?
They're right.
Good. These are perpendicular, so each of these are 90. Now, I already have it labeled, so it should be easy to answer these. Angle ACD, which is here, is 62 degrees. Angle DEC, which is here, is 90 degrees. EDC, which is here, is 28 degrees. And ABC is this whole angle, which is 56 degrees. Questions on any of those? So as soon as you see rhombus, you've got to know opposite angles are bisected, and you've got to know that the diagonals are perpendicular. Okay, now this one is saying it's a rectangle. So what do I know about the angles in a rectangle? They're all 90. This is 90, this is 90, this is 90, this is 90. So this would be 61 degrees. Are the opposite sides still parallel? Yeah, so my alternate interior angles still apply, right? This would be 29. This would be 61. What do I know about the diagonals? Alexis? They're bisected and congruent. So if LN is 12, then PL is 12, ML is 12, and LO is 12. With me so far? Yep. Okay, now diagonals are not necessarily perpendicular, so I don't know anything about where these meet, those angles. And all I know about the MPO is that it's a right angle. I don't know the individual parts. So when it asks for PON, it's this angle here. We said this was 90 degrees. PMO is this angle here, which is 61 degrees. PL is this segment. We said that's 12. And MO is this whole segment, which would be 24. Good. Questions on any of that? Everybody still good? Okay, so now a little bit of algebra thrown in here, right? So we've got expressions instead of just numbers. And notice it's a square, so all the things you already know about rectangles and rhombuses apply. All right, so I'm going to start by labeling what I know. So ME is 7x minus 3. MO is 6x, and it wants you to find x. So what do I know about both those sides? Because it's a square, which is a rhombus, they're congruent. So 6x equals 7x minus 3. If I subtract the 7x, negative x equals negative 3. Divide or multiply by negative 1. And I get x is 3. Raise your hand if you got it right. Good. Okay, second one says MT is 4x, and TE is 3x plus 2. So now we're using the properties of, again, a rhombus. What's true about the diagonals? well, actually the rhombus and the rectangle put together. They're bisected and they're congruent, right? So MT is going to be equal to TE. So 4x equals 3x plus 2, and x equals 2. And then the question is, what is OE? So I've got to take the 2 and plug it back into that 3x plus 2. 6 plus 2, which is 8. And then how do I get OE? Multiply by 2 or double it, right? So this would be 16. Questions on that one? Easy stuff, right? Hardest part is figuring out which one goes with which. So that's why when we started this chapter, I said maybe this is one of the chapters you want to create an outline for, and I would recommend keeping those properties like written on those. So now we can add squares, rhombuses, and rectangles onto that list of parallelogram properties.